Okay. Okay, so let's start for today. So today we are going to solve our first question is binary path. And in binary path, let's read our question and listen what we have to do. In a given road of a binary tree, return all route to leaf path in any order. Okay, so uh, okay, so according to our question, like if we have a binary tree like 1, 2, 3, 4, and 5. So for this, our output should be okay. What is the uh, from root to uh, our starting position will be root, and the our end position will be leaf. So we start from 1 and we have to end with 2, 4, or 5. So we have to give all the path that is possible. Like in here to from 1 to 2, we have to reach. It's just simply 1 to 2. And if we have to go to 1 to 4, it will become 1 to 3, then 4, and we have to go to 5. So 1, 3, and 5. Okay, and we have to give output just in the same way. Let's see. Are there? Let's read one more time. Let all the route to leaf path. Okay. Is there any possibility to like if I want to reach at a node, are there multiple ways to reach their node? But because it is a tree, I don't think there is a uh, node in which there are two ways to reach. Five, six. And there is no way to reach to a leaf more than one way. There's only one way to reach from root to leaf node. There is always only one way. Let's ask our ChatGPT is it possible to reach more than one way? Yes, there is a possibility to uh reach leaf node from node more than one way. In short, in binary or anomaly, there is only one unique path from root to leaf. Okay, yeah, we are right. There is always only one way to reach from root to node. So now we have to find like how we are going to give this output. I think we have to take a array with us where like here 1, and when we reach to 2 that array will increment to 1 comma 2, and the same array will go here 1 comma 3, and because to reach 5 we have to go through 3 to 1 3 and 5, and when we have to reach 6 it's 1 3 5 and 6, and to 4 1 3 4, and to reach 7 1 3 4 and 7. So these while traversing we have to take a list with us and update it, and as we reach to our leaf node, we just have to append that in our answer list. Okay, let's write a group a rough code like what we are going to do. Left traverse, there will be a root, and with root we are going to give a list also with it. And if not root, then do nothing, just return. If you are in on a root, then just append this root value in the list. Just append whatever the root value is, and after that, after appending, we have to we have to go for left. So what I have to do? Traverse root dot left, and then value. Sorry, list. Okay, this is simple traversal. Okay, in this traversal, we also have to update the if we reach to leaf node, we just have to hi Abhay. So okay, so we have to add a condition here. So that condition will be to find the leaf node. If root dot left dual equals to root dot, where are you from? I am from UP, Kanpur. So root dot left, root dot right, and double equals to none. And these both are agar none, that means it is a leaf node. And if it is a leaf node, then just I have to do, it is an answer in our global. Oh, nice. So, okay, none. If both are okay, none, then what I have to do? I have to append this list in this. So we are not going to append this same list in this answer because we are taking a pointer of a list. So we have to make a new copy. Okay, copy of this list in the answer. So answer dot append the list copy. Okay. So and after appending we have to traverse, and here we will put else condition, and in else condition we have to traverse, and after traversing we are going to just pop this list whatever we have appended. List dot pop. Okay, so in this way we'll get over all these things, and to add these arrows in all, like, because what we are getting is list of list, like this thing. Okay, and we have to convert this thing in a string, like for the output. So for that, what we have to do is we have to use the dot join, and join take a list, and I think it take a list of strings. So I also have to take each element and have to change those element in the string, map that thing in a string, and I have to pass a list also. So list will be whatever the list is. So this thing, and this whole thing will be in a loop for list in answer. Okay, this will be our one line, and this we are going to return. Okay, let's code it and try check if this works or not. Okay, so here, okay, so what we have done, let's make a global variable answer, and in answer we have to make a function in which we have to traverse in whole, in which, because root is already there, so we will take node as a variable, and a list, and for list let's take it as a path, and in path, okay, so let's start in this. If not node, then just return to nothing. If there is a node, then just add that guy in path dot append path dot append the node value. So node dot val, and after that, if node dot left double equals to node dot right, and double equals to is none, then it means it is a leaf node, and if it is a leaf node, I have to put the path copy in our answer as insert dot append path dot copy, and if it is not, I have to just traverse in other, traverse node dot left comma path, and same for traverse node dot right comma path, and after doing this I also have to pop these guys out. So path dot pop, whatever element I have put it in. So this will be our final code, and now I have to call the traverse with root comma empty list, and after that I also have to return the value. To return, I have to make a list in which there is an arrow dot join map the integer into the strings, and the list, whatever we call it as a path, and for path in the our answer. So this will be our code, I think. Okay, let's check. Okay, what I have done wrong. Okay, okay, I have put this in. Okay, okay, I think okay, both cases pass. Let's run this. And it ran. Okay, nice. So we have done the recursive solution, and now we have to do the same without using the function calling with the help of stack or queue, with the help of traversal. To code this in traversal, so let's see how we will code. Because we are going to do same thing, so it will look like it will look as it is. So we will make an answer, and we are also going to make a path, and in place of function calling again and again, we are going to use a queue. Okay, the queue, and queue is equals to the queue, and in queue we are putting the root, and let's first check if root is present or not. If not root, then just return the empty array. Uh, there is always a one node is available, so I think there's no need of this. So while you just pop this guy out, put it in a node. So node is equals to, no, it is not Java printf, it is Python. So in node I have q.path. What you study? Uh, I was I was a BTech student. Okay, so q.pop. So now I'm working in a company. I'm employed. Yeah, I have a job. Yes. So which year was it? 2024. Okay, so not Oh, which company? It's TCS, bro. Okay, so q dot pump and okay. If no dot left, no dot uh, guide me, bro. It's my third year. So if you are in third year, Java calls large enterprise. Just have in Java. Yeah, they are in Java, but I don't like Java, so I'm not going to use Java and learn Java right now till I don't get the project in Java. I prefer to go with app development using the Swift, Kotlin, or JS something. But I don't want to go with Java till now. Work from home? No, no. Not work from home. It's work from office. But right now I'm on bench, so as a side hustle, I just started this streaming and doing some DSA. Okay, so right. And okay. And for this, I also have to put this node value in our path. So path not append. Still project not allocated. No, I just joined the TCS. So I was on a training for a month and I just on a bench for a week only. So I'm waiting. So path dot append the node dot well and after pending copy and then so you have a year gap. No, no, I don't have a year gap. For a year I worked in Accenture. Okay, answer dot append. If there is no like it is not leaf node, then just what I have done in this, I put traverse. So in the place of traverse, I will just add this in our queue. Well, I think I'm doing something wrong here. I should be not using the queue. Yes, I should be not. Like if if I am using queue, so first thing that will go in our queue is one, and that will go in our answer. Right now is zero, and let's put path here first. queue and our path. So it's 1. So in path is also goes 1. According to queue, when I'm 1, I will put 2 and 3 in here and pop out this guy, 2 and 3. And as I go to 2, popping out 2, putting it in our path, and also we know that checking that it is a leaf node or not, and it is a leaf node. So I put this 1 comma 2 in our answer list. Okay, and after that I will go for 3 and putting it at 3. So this will break our I should have to pop this guy out, but I'm going to 3. So in place of queue, I should be using the stack. So if I had used a stack, okay. So first put 1, and as I pop this guy out, it will be in path, and I'm using stack, and I will put right value first and then left. So right will be 3, and then I'm putting right first and then left. So 3 and 2, and then I will pop out 2, putting it in path, and also checking 2 is also already in this so I will append this in our answer, and after appending I will just pop this guy out because I have already put oh, I will never put the pop here. So it's path dot pop. Okay. Okay, so after popping this, I will go for 3 and popping this out and putting this guy in here. And we know 3 is not a leaf node, so 4 and 5. And we know we are traversing right first and then left. So putting the right here first and then left. Okay. And now I have 5 and 4, and I have to pop 4, and after popping 4 from our stack, and it will go in our here, and we know 4 is also not a leaf node, so it will give 7. Okay, wait, I am popping in each case, so our list will not increase. So here I'm doing something wrong. Let's understand our solution. So in place of Q, I have to use a stack. The first mistake I have to make it right. So uh, place of Q, just set it up and from Q stack. Okay, and now I have to find the condition in which I have to pop this path out. Okay. One thing I can do, let's find out this. Okay, so where I should pop this statement in, like if it run, okay, so I am in queue. Sorry, here I also have to change the stack. Okay. while stack it is a root is there. I put that I popping that guy out from our stack, putting that in our path, and checking for if it is uh, leaf node or not. It is not. Then then we are going and appending both guys. And after appending, this thing should be not here. So now the real problem is when I will pop these guys out. So left and right, going left and right, and one by one unpending. And as I find like here, I will pop this guy out. Okay, so I think this will not work the way I wanted. I have to put the path with our root comma a list, and here the node we will get, and a path we will get, and we will by appending that our path. In place of appending in our path, we have to make a new list. Okay, so I have to remove this here, and here whatever is our uh, path plus whatever it's in our node dot var path plus. I think it will fill up all the memory. Memory is executed type error. Please don't be there. Okay, answer. For answer, I have to use this. Copy, paste. Okay, see. Okay, okay. I am using keyword. Should be stack. List.append takes exactly 1. Okay, I have to just add one more. Okay, none type. Okay, if not node, just continue. The output is 1 and 2. It is 1, 2, 5, 1, 3. Okay. I am using stack with the empty list, taking it in a path, just not do nothing. If there is a node, and I just don't have to focus, just take that path in our answer, and in else condition, I just have to append whatever the path is. Okay, path plus whatever the present node dot value. It should give memory limit exceeded. And it works. It works. I really didn't expect that it will work, but it works. The now problem what the problem I'm facing here is the memory using is way more than anything. Like when you will come out from the stack, okay, I'm also not able to show that memory. I have to optimize this because it is using too much memory, like path plus node. Well, this will make a new list. So how I should do this? I'm not able to remember. There is a way like to do the same traversal without using extra memory, but I am not able to remember that. Like I have a stack and there is a sorry, a tree, and I have traverse in it. And there is path. So in a stack we have our root stack. If if okay. So I will put this thing in another node. This equals to stack dot path. This will get a present node. Okay, and as I get the present node, I will put this in our path. Whatever is node is, and well, I have appended this in our stack, and now I have to traverse both in both direction. But I also don't want to use extra memory like in previous what we have done, like this list. So how what I can do, I traverse from here to here. I will cut this in our stack, and if I'm in this node, I also have to take this and this same both values left and right, and because we are traversing first and left, so I have to put the right first and then left. So that I can pop this guy out, I will be in here and just assume like I don't have this. So now while I going back, I have to pop this guy out. Okay, yes. I'm not getting any solution to optimize it. Let's give it like 6:49. Let's give it one more minute. Maybe we can find, if we not get any solution, then we see other solution. Maybe someone more better than a better programmer, DS expert can give the better answer. Okay, so I'm going back. So the problem is I'm not going back because it is not a recursion. I'm going directly here. So when I reach here, I should be removing this path, like this previous, whatever I am appending in the path, I should be removing it. First forward and then left. But sorry, I'm not able to find any way and it's already time. So let's see other solution. Maybe someone use more optimized way to solve this thing. Hmm, Solutions, Python, and let's go with this guy. Okay, TFS. I don't want this solution. Font traversal. Is there anyone? Okay, stack guy is there. Mm, In a stack, maybe that path is simple. Hmm, Why he has used this? quick- He should have just used this simple one-line code. Well, I think he didn't know Python. He is not a Python programmer, it means. But let's see. So what he has done, getting a path and a stack, and okay, as he get in stack. So okay, while left, as you get all the left, he's just appending those things and in the path also. And PTR is equal to PTR left. Okay. And if PTR right, then start is equal to PTR right. Okay. Okay, so he goes first in all left, and then when there is no left, in when there is no left node is available, then he check for right node, and if both nodes are not present, so now what he is doing, answer dot append self get path at path, and while at path, if ptr left and right, ptr dot left is equal to none, and he's breaking the path also in between. He's breaking the whole tree, I think. So this is not a good solution. He's breaking the whole structure of the tree. No. I don't want to break the structure. See this guy. Okay, I think the same thing that I have done is this. Yeah, the same thing that I have done for a path. But this is better. Like he's using a string, and the string will take less place. then my list, which I'm copying them again and again. So this is a better solution, but still it is, I think I can get any other that is more optimized than this. Yeah, this guy has a test-based optimization. And stack code 0, path and result. While stack current and level. Okay. He's taking level with it. Okay. And if level is less than length of path level is clear current level, else path append. Path level. Okay. Yeah. He's taking level, like he's saving all the levels in the path, a list of list. If not current left, then current right. So my conditioning path 0 to level is 1. Okay. Okay, now I get it what he's doing. What a very clever solution, I think. So, what he is doing, so if 1, 2, 3, 4, what he's doing, he's taking the levels. So if it is level 0, then this will be 1 and this will be 2. So what that guy has done, he make an array of path, okay, while traversing using the stack, like let's make a stack also, and an answer. Okay, so in a stack first over 0 was there, and with its like so this stack contains its node with its what we are saying this thing, level, with level. Okay, node with level. So as he is in 0 comma 0, no worries, he will check that in an answer if there is an index present with the level 0. It is, so he will just overwrite it, or if it is not present he will make it. Okay, so 0 comma 0, and as we will pop this guy out, we put the file because it is a stack, so 1 uh 1 comma 1 and 2 comma 1. Why are you live stream tutorials? Well, it is just for myself because if I don't live stream, then I will just study for 15 minutes and play game to make myself study. I'm just doing this. So just for myself. That's why I'm not editing and saying subscribe or something. It is just for myself. Yeah, I know it is a cool idea. Okay, so here is 0 comma 0, and then I go to 2 comma 1, I'll just pop this guy out, put the index whatever it is, and here is 2. And after this, again, because we have popped this guy out, we have to append its left and right. So 4 comma 2 and 3 comma 2. And as 3 comma 2 will be popped, so 3 3 will be here and here will be 2. And we know this is a leaf node. We will check if it is left or right is available or not. If not available, then what this guy has done, he just append this whole, oh sorry, okay, what I was saying, not ans it is a path answer. So he this copy the this path and put this in answer. So 0, 2 and 3. He got a path. Okay. So for further process, what he has done, now he has gone to 4 comma 2. Okay, pop this guy out, and in place of 2, he has just override this in place of 3, override this with 4. And now we know again that 4 is also a leaf node. So now he took this from starting to this path, whatever its level, we know its level, and just again putting this in our answer. So here comes like a very innovative way that I never thought of it. So now what he has done, like now in our stack only 1 comma 1 is left, and while popping this guy also out, so 1 comma 1 here 1 and 2 will be also replaced with 1. So now what he has done, he has just traversed only to the level, checking the level. So in path, he is going from starting to only level plus 1. So it means this now, so this he will append. Okay. So now it will only append 0 to 1, not this. So now we will get the 0 comma 1. A very like I love the this way of solving thing. Not using any extra space, just like it is like for me it is a very innovative way to solve this question. Okay, let's code it without seeing its solution. I don't know. Okay, so okay, let's see. Will I be able to code it or not? Uh, uh, what is I've done something wrong here. Yeah, I knew that. Okay, so this is also, so let's put double underscore doing something new. What he has done, innovative solution. Okay, so what he has done, like first he has make a stack, and with in stack he put the root, and we only already know that there is always a one node available, so we are not going to check if not root or something. So root with its level 0. So I will comment it on and check its node and the level. Okay, and after stack he put the path, and in path nothing, and in answer right now nothing, and for so while stack, so he pop out the whatever his node is, and after node whatever its level. So in level, so stack dot pop, he pop this guy out, and what he has done, putting this in path if if length of path is less than, sorry, is greater than or equals to whatever the, no, no, greater than level. If this condition satisfies, then just put the path dot, sorry, path and whatever is level. Okay. L E L E V E L. Okay. Path level person node dot val, and in else path dot append the node dot val. Okay. And after appending, uh, what here, I have to check if node is a leaf node or not. If node dot left double equals to node dot right and double equals to none, and if it is a leaf node, then just take the whole path, put it in our answer. So answer dot append the whole path, and that will be uh, here dot join map, make everything in string, and the whatever is path. Okay, this thing we have to append, and after appending, and one more thing from here, this is the very crucial thing that he has done. The path, not the whole path, only to the level that is given. Level plus one, and then else just a normal stack. So go left and right. So it will be if it is so, what I have to do is stack dot append not dot left, and stack dot append not dot right, and with its level. So whatever its level will always be plus one, and one thing I missed to put it in tuple. So it will work, and I also have to check if it is like I'm putting left and right node in a way. So and I am not checking if node is there or not. If not node, then just continue. And I think this should give our answer. It's just complete, I think. Well, I think I have done something wrong because it is taking too much time in the test case. Please work. Okay, let's see what I have done. Using stack, node level. I am taking the node and level. Stack row, path, answer, returning the answer. And also I'm putting this in the string. Seriously, why it is taking this much long? Okay, let's level, step up, if not node. Ah, it worked. It worked. Let's see. Will work or not. Please work, bro. Please, please, please. But and it really worked. Okay. Uh, okay. It is done. Okay, so let's go for next question because we have already done this question using three ways. Okay, so let's go for second. The path sum. Given a root of a binary tree and an integer, target sum return true if the tree has a root to leaf path such that adding up all the value along the path equals target sum. Okay, root to leaf path. I think we have to solve this question in the same way as we have solved the previous question because in previous we have to take the each nodes and in this we have to just take the sum. So the recursive solution should be same. So well, let's write its recursive solution because it will be same as we have done in this. In here, in place of path, we will take sum. It is the only difference here. Okay. Okay, so let's start and code it with recursion because it is going to be same. Um, so root and target sum. And I'll leave for what I have to return first. I have to check if the given binary tree return okay true or false. And because target sum is written here already, so okay. If not root, just return um false. Okay. And if there is root, then just decrease the target sum. So target sum minus equals to node, whatever the root dot val. And after decreasing, if uh, if target sum double equals to 0, then just return true. Okay. And if target, let me see if positive negative numbers are present or not. In constant, yes, there are negative values. So else condition will be not there. And else, if target sum is not equals to 0, then just go for left and right. Path. Okay, I have to also use self dot has path sum root dot left comma whatever is target sum. And with this I also have to and or self dot has path sum. Okay, so here we will go for root dot right comma target sum. Okay, return true, return false. If I'm going here, so return false. Oh, sorry, sorry, not here. Here. Uh, this. Okay, this will give what we wanted, I think. Yeah, it works. And let's submit. And it failed. 1 comma 2. Target sum is 1. And the expected is false. And I'm giving true. And the reason is okay. The target sum should be equals to 0. And the one condition I just forgot is that root to leaf. There's one more condition that it should be leaf. Okay. And root dot left, root dot left equals to root dot right and equals to none. Okay. So these condition when follows, then this will be true. And if this condition not follows, go for next. Okay, and if not true, then return false. Okay, nice. Let's see if this work or not. Put this in our use case and run. And I got an error. So let's see why. Okay, here syntax error. Yeah, it works. It really works. Okay, nice. So it's recursive solution was literally very easy, and now we have to code this whole thing in uh, non-recursive way. Okay, and okay, so what I have done here is not true. I'm just taking the whole sum. So, like in our stack, I'm going to put whatever the root is. It doesn't matter. I should use a stack or um, root with its sum. That is right now it's whatever is root dot var and while stack if okay. So if not node just sorry, if not node continue and node is equals to stack dot up and continue, and after this while stack knows and what I have to check the condition. If node dot left, first check the sum. So the present sum should be what is the root and root value, and okay, node with its sum. And if sum double equals to 0 and node dot left double equals to node dot uh, node dot right double equals to none, and if this condition follows, then just return true, and if this condition not follows, then if node dot left then go left, stack dot append um, dot left, comma, whatever is sum is plus node dot, sorry, node dot left plus plus yeah, node dot left plus val dot val, okay. And I have to do same for here, node dot right, stack dot append, node dot right, comma, sum plus node dot right dot val. And after doing this, if I don't get the solution, then just return false after the while stack. Because if I get in between anywhere our answer, then it will return true automatically. Okay, so let's see if this works or not. Okay, none type object has no attribute val. Okay, if I didn't check if this condition is here. Okay, zero. Yeah, there is a possibility that there is not a single note here. So if not, root return false. But there is also possibility if there is if not root, if target sum double equals to 0, then return true, else false. In case 1, it doesn't work. Case 3 doesn't work. Wait, then okay. Case 3 target sum output expected is false. Okay, it will give false by default. I don't have to add these arguments. Okay, so here what is going wrong? Let's understand. So stack root dot root val and whatever it's stack node and then sum, and after the sum, if not node, then just continue, do nothing. If if not node will not come because I am already checking it. So if sum node is equal to 0 and node dot left and over not equal to none, then just return true. Okay. And in else, if node dot left is present, then append that node dot left with the sum that is I got here with whatever the node dot left dot value. So I think it is okay. Sum dot append node dot right, sum plus node dot right dot val. It's wrong here. Target is 22, output is false, and expected is true. Let's see test case how it is okay in this, and why I'm returning false. What was 22? So 5, 4, 9, 11, 4, 6. Okay, so this is the path in which the output is correct. So what is wrong in my code? I'm using stack, and it doesn't matter what I should use because whatever the value I get, it is independent. Okay, and whatever I am getting a sum is from the root node, and I'm just adding that sum with the other, like if I'm going left, get check. So the whole code is right. I think there's a some minor mistake I'm doing that I'm not able to see. Let's ask ChatGPT, maybe that I will find out that minor mistake. I see a bug. Your code is very close. Okay, in your defaces loop. Um, if you are checking sum double is equal to 0, but what we are actually what? If we are at leaf and the path sum equals to target sum. Oh, bro. Seriously. No, bro. I why I didn't check that? Yeah, target sum. We are checking target sum. Okay, yeah, it works. Okay, so the second solution was really easy. Like second question was really easy, but it was just my mistake. I'm doing something unexpected. Okay, so now here is the next, that is medium level, and I have half an hour. Next is hard, so let's go with path sum 2. And okay, given the root of the binary tree and an integer target sum, return all the root to leaf path where the sum of the node value in the path equals to target sum. Wait, this is like same question. Given a root in the binary tree, just target sum, return all leaf to root. Acha, okay, in this I also have to return the path with the sum of the node values in the path equals target sum. Each part should be returned as a list of the node values, not node reference. So this is the same question as we have done previous, like this one. I just have to get each path. While getting each path, I also have to get the sum. Okay, so with sum, I have to also add a one more variable, and I have to return the. Okay, I have to do same thing with a little bit changes. So I am going to do save code. Let's copy this. So let's don't copy. Let's code it. Okay, be more better. So here is path. Do nothing. And now I have a def and traverse. And traverse, I have to put the whatever our node is. Okay, node, and what I have done in node and path. No, 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 no. Okay, yeah, same thing. Okay. I think okay, I will put path here, and here I will put the sum. Okay, we'll take sum with me, and if not node, then just do nothing, just return. Okay, and if there is node, if sum double equals to target sum, and because I also have to go to leave, so I also have to check is if uh, hi Adarsh. If node dot left double equals to node dot right double equals to none, and if this condition satisfies, then just add this whole path in our answer. So our answer stack. So in our answer, I have to just put these things. Okay, so in our answer dot append like path dot copy. Okay, so after this, I have to just go for node traverse in both direction. Traverse node dot left comma sum with whatever the node dot value. Without degree or with degree in the field or BTech. Well, with degree, I'm BTech student, BTech computer science. I was a computer science student. Right now, I'm in a company. You can see the whole chat in this. You can find out, I think, everything. Okay, so node dot left, some. Oh, thanks. Okay, so okay, where I was. Traverse node dot left, some plus node value, and traverse node dot right, commas, some plus node dot val, and after traversing, I also have to pop this whatever we are appending in our answer in our path dot pop. Okay, so what not now path dot append node dot val. Okay, answer return. Okay, so I think this should complete our code. Same code, but only one new variable, that is sum. And it works, but for a case it doesn't work. The output is nothing. You work in TCS, damn bro. It is nothing damn in that in this company, bro. Okay, so okay, it's not node. What is gone wrong in here? Let's see the test case. Okay, here. And according to test case, there will be two output 54112 and 5845, but I'm not getting a single one. What could be a reason? Like in previous solution I was taking path with me, and then published that, but it was not needed. Okay, it isn't as it that would be a good experience. What is the work you are doing in TCS? Well, I am a software developer, like say system engineer. Okay, yes. Okay, wait, I have to end this here because I have a call, an important call. Sorry for this, guys. Let's do this question again tomorrow. You will get a college, bro. Don't worry. Okay, so good night for today. We will start from here again. I will not solve more. Okay, I have a call to pick up. Good night, guys.